All right, the main part of this set that I want you to understand is numbers 8, 9, and 10. When we get down here at 11 through 20, if you're not really having any luck coming up with stuff on your own, don't worry about it. It's sort of some abstract thinking at the end that we want you to do. So looking here at number 8, they're asking us several questions. First thing that you need to realize is that this is a function going to negative infinity. So always assume that those arrows on this function are going down unless told otherwise in this packet. And same thing over here, this one's going forever to infinity as well. So draw those in, that'll help you. Okay, domain of every parabola, domain of every absolute value function goes from negative infinity to infinity when it's a function. See how it's going forever left to forever right. Your range is going to go from negative infinity at the bottom up to the maximum of -1. This is included and this is not. Range of this one goes 1, 2, 3 from 3 to infinity. 3 is included, infinity is not. Next is the intercepts. We've got both x and y intercepts. For the x-intercepts, there are none. This is a graph of a parabola that never touches the x-axis. No x-intercepts. Okay, what about the y-intercept? There she is right there at 0, -1. On the next one, do you see any x-intercepts? Okay, no x-intercepts on that one either. And then for the y, it's at 0, 4. Okay, minimum and maximum. Your max is at y equals -1 when x is 0. And your minimum is that there is no min because y goes to negative infinity. Your max of the next one is no max because y goes to infinity. But your minimum goes through y equals 3 when x is 1. Interval increasing, I'd say it increases from negative infinity to 0. And then it decreases from 0 to infinity. And I'm actually going to include the 0 here, but not there. Interval where the function is increasing goes from 1 to infinity. Is our increasing. And then our decreasing goes from negative infinity to 1. Sorry, on increasing and decreasing, we're using calculus definition, all open brackets. Okay, we answered everything on numbers 8 and 9. Let's now look at 10. Picture 10 touching at -3, 0. So let's picture sketching this graph. And then you've got a part that's going down at a slope of 1 and a part that's going up at a slope of 1. There's your V graph, parent stretch of 1. So picturing this now, our domain, forever left, forever right. Oh, there's my blue. Okay, so forever left to forever right. And then my range goes from 0 up to infinity. My intercepts, this one actually has an intercept at -3, 0. And then let's see here, 1, 1, 1. So that's going to hit at 0, 3 for the y-intercept. My minimum of this graph, the max is no max. My minimum is through y equals 0. Interval where the function is increasing goes from 3 to infinity. And decreasing goes from negative infinity up to 3. Okay, how'd you do on those guys? All right, again, if on these ones it's not coming to you to think of one on your own, just kind of see if you can picture what I'm doing. So we're writing a function that meets the given requirements. We need a function that's always decreasing. So I could write something as simple as like negative x. Can you picture that, a line that's always going down? Or negative 2/3 x plus 10. Again, that's a line that's always going down. So a nice line with a negative slope would work on that one. You write your own function that's always decreasing if possible. Okay, a function that's symmetrical about the line x equals 3. So if you want to picture at 1, 2, 3, something that's symmetrical around that. Can you picture a parabola by chance? And you can make your vertex whatever you want it to be, but it's going to have to be 3 something. It could be 3 a negative number. It could be 3 a positive number. So if I made it 3, -1, for example, with just the parent stretch, that's my HK, then here comes my function. Parent stretch of 1, x minus 3 squared minus 1. There's an example of a function that's symmetrical around the line x equals 3. You try to write one for yourself that's slightly different. Okay, a function with a minimum of 5 at x equals 1. So 1, 1, 2, 3, 4, 5. Oops. Okay, so I could go x minus 1 plus 5. That's going to be an upwards parabola where its vertex, its minimum, is at 1, 5. You try to write one that has a minimum at 5. A function that is increasing from -infinity to 2, and then decreasing from 2 to infinity. So we're trying to write an absolute value function maybe for that, or a parabola that's upside down. So I'm going to write this as a piecewise, where maybe it goes, sorry, we need to make it positive first. Positive x minus 2 plus 5, and then negative x minus 2 plus 5. And this is for x values less than 2, and then x values greater than 2. Okay, so there's one function. It's a piecewise function that's both increasing and then decreasing on that domain. A function with one real root. Ooh, this is a good one. What's my one real root of this? Well, if I solve both those factors, my one real root is at 6. A function that has a domain from -2 to infinity. Ooh, I'm going to do the swoosh. So that would be the square root of x plus 2, because it has to go back 2 on that domain. F of x equals square root of x plus 2. A function with a range from 0 to infinity. So picture this. F of x equals x squared. A function with a common factor of 2. A function that's also a geometric sequence. Geometric means multiplying or dividing. Could be also decreasing like that. And a function with x-intercepts at -1 and 1. Okay, so these are just some ideas. How did those go for you? Was that like, whoa, totally confusing, or did you sort of understand some of those? I hope that was kind of fun for you. It was for me.